Hello, Professor. Today we'll be presenting a term project on analyzing high volume taxi data, which explores patterns and trends in New York City yellow cabs for DSC 501 course. Our team members for this project are Aman, Ishan, Shushma, and I, Shruti Kirtana. Here is the table of contents for our presentation. We'll cover each of these topics in the upcoming slides. Our primary goal in this analysis is to examine the demand for taxis based on factors such as time of the day, the days of the week, and locations across New York City. By analyzing these patterns, we aim to uncover insights that can help improve the efficiency and availability of taxi services. Now let's start with the overview of the dataset. We are using the January 2024 New York City Yellow Taxi Trip dataset from the New York City Taxi and Limousine Commission. The dataset contains around 2.96 rows and 19 columns, capturing the operations of New York City's busy taxi system, which serves millions of people daily. Some important columns in the dataset include pickup and drop-off times, trip distance, fares, payment methods, and passenger counts. The dataset is regularly updated and reflects real-time taxi operations, which makes it useful for understanding taxi demands in the city. First, we clean the data by handling missing values and by removing outliers and fixing date-time formats to ensure the accuracy of our analysis. Additionally, we also created features like day of the week and hour of the day, which allows us to better analyze the patterns. Now let's take a look at univariate analysis for key features that helps us to understand the demand patterns. First, the count plot of passenger counts show that most taxi rides have only one passenger. This means that the majority of the taxi demand is from individual riders, with fewer rides involving 2 or 3 passengers and even fewer with more than 6 passengers. Now let's look at the distribution of trips by vendor ID. Vendor 2 handles the majority of rides with over 2.2 million trips, while vendor 1 has around 729,000, and then the vendor 3 has 260. This tells us the vendor 2 is handling the highest demand, while vendor 1 and vendor 6 have much lower demand. The next plot is the trip distance. The average trip distance in New York City is around 3.65 miles, meaning most taxi rides are relatively short. This suggests that the demand for taxis is mainly for local trips. Although longer trips do happen, they make up a small portion of the overall demand. When it comes to payment, the most passengers pay by credit card followed by cash. This shows that most passengers prefer the convenience of electronic payment, which could indicate that tourist or business travelers from a large part of the demand. Here we see the distribution of taxi rides based on pickup and drop-off days. Weekdays, especially Wednesdays, have the most trips, like to people commuting to work. In contrast, weekends, especially on Sundays, have fewer trips, suggesting taxis are used less for leisure activities on those days. The next plot is trips per hour. So this plot shows a distribution of taxi rides by pickup and drop-off hours. The busiest is between 5 p.m. to 6 p.m., which aligns with when people are finishing their work and heading home. This suggests that evening commuting creates the highest demand for taxis. We also see that the afternoons are the busiest time of the day for taxi rides, followed by the evenings. This shows that there's a higher demand for taxis during the afternoon and evening, likely due to work-related and social activities. Now let's look at now in relation to time, hour, and week. The first plot shows how far people travel at different hours of the days. We notice that the longest trips tend to happen around 5 a.m., likely due to early morning commuters or airport runs. This shows that there is a more demand for longer trips at that time. The second plot shows how trip distance changes during the day. We see that longer trips happen mostly in the morning, possibly because people are traveling to work or engaging in early morning activities. This indicates more demand for longer trips during the morning. Lastly, the plot shows the how trip distance is during the week. We see that longer trips happen more on weekends, possibly because people travel for leisure or other activities. This suggests that higher demand for longer trips during weekends. Now I'll hand it to Shushma to continue the next part.
I'll be presenting an analysis of taxi demand patterns across NYC. The goal of this analysis is to better understand patterns across the city, identify high demand areas, and frequently traveled routes. To do geographic analysis, we mapped location ID with place names and latitude, longitude of all 5 boroughs of NYC. Next slide. Uh, this slide shows top pickup and drop off locations. Top pickup zones are JFK Airport, since many people will be traveling back and forth for holidays and this is a New Year season. And Upper East Side and North and South has highest drop-off activity, likely due to mix of residential and business areas in shopping centers. Midtown also see a large number of drop-offs. Next slide. This slide shows high frequency routes. Um, Here, one significant trend which is frequent travel between Upper East Side, North and South. These areas shows a lot of intra-area movement within local of Manhattan. Next slide. We created a heat map to show density of taxi pickups using KDE, kernel density estimation. Manhattan, particularly Midtown, is where we see the highest concentration. On the other hand, Staten Island and parts of Bronx show the minimal activity. Next slide. This is interactive map of density visualization. Earlier it was graph. Here we have plotted density on map. To see visualization of density, here red dots show the highest density areas and the blue dots show lowest density areas. Uh, so this helps us to explore trends in more detail. And hotspot refers to areas which significantly has higher trip counts. This helps us to understand distribution of taxi trips throughout NYC. The red circles represent high demand pickup locations. Here we can see JFK, Airport, LaGuardia Airport, and most of the hotspot areas are in Manhattan. Next slide will show the ranking and pickup numbers of each location. Here, all the red circles represent hotspot locations and rank and pickup numbers. Next slide. Uh, Conclusion of this geographical location analysis is high demand areas are JFK Airport, Midtown Center, and Upper East Side. These are the busiest pickup and drop off locations in NYC, which is mainly Manhattan borough. Out of all five, Manhattan is the busiest city. Uh, and these insights can be applied in several ways. More taxes can be added to high demand zones, and taxes can be redistributed to areas with lower activity. And this can help improve connectivity between places, and companies can use this info to refine price models, optimize driver incentives, and better serve high demand areas. Ishan will continue the presentation.
Yeah, hi. I'll be presenting our analysis on taxi demand patterns, focusing on daily patterns, customer trends, and future forecasts. Let me begin by explaining what Y hat represents in our analysis. Y hat is a statistical term that represents our predicted or forecasted value for taxi demand at any given time point. When we see a Y hat value of 1.0, this indicates our baseline demand. Think of it as our normal level of taxi orders. Value above 1.0, such as 1.08, indicates demand that is 8% higher than normal, while values below 1.0 suggest lower than average demand. Looking at our daily pattern across the week, we observe remarkably consistent demand levels. The hourly distribution plots show subtle variations in wired values between 0.98 and 1.10 throughout each 24-hour cycle. Each day maintains a stable pattern with valuable insights for basic resource allocation. Next slide. Our customer trend analysis reveals fascinating patterns throughout the day. We observe peak activity at hour 15 reaching a Y-hat value of 1.08, followed by a steady decline into the evening hours, eventually reaching 1.00. This declining trend is particularly valuable for understanding daily customer behavior and optimizing service delivery during peak hours. Next, next please, Shruti. Finally, let's examine our future predictions. The time series forecast for February to March 2024 shows increasing volatility as we move forward further into the future. The Y hat values fluctuate between 0.98 and 1.10, with the amplitude of these fluctuations growing notably by late February. These growing volatility is typically typical of long-term predictions and suggests the need for more flexible resource allocation strategies as we move further into the future. These insights provide a robust foundation for operational planning and strategic decision making in taxi service industry. The combination of consistent daily patterns and predictable trends quantified through our values offers valuable guidance for optimizing taxi service across different time periods. Now, Aman will take it forward. Uh,
Thanks, Ishan. I'll take over and shoot for the ANOVA analysis that we did. Analysis of variance, also known as ANOVA, is a statistical method which we will use to determine significant differences between the mean of three or more independent group. Here, the hypothesis might be wrong or right, depends on the analysis. Also to analyze the impact of categorical versus continuous variable, which we will be using in the ANOVA testing. Also, below is a box plot, which shows a distribution of passenger counts for each day of the week versus passenger count and day of the week. So here we observe is that the outlier data point, particularly for day 0, 1, 2, 3, 4, which is representing weekdays, suggesting that there will be some days with significantly higher, and 6 and 5, which are weekends, which suggests that there's a higher demand on weekends. Next slide, please. Here, we continue with the analysis in a deeper restoration. We choose these columns from the data set because they likely will have, and we have checked it, that they have a normal distribution, which is a prerequisite for ANOVA. Let's understand the table. The vertical scale consists of the R day of the week, R day of the week, and it's interacting with the day of the week. And also there's a residual, which is error or noise in the data. On the horizontal side, we have sum square, DF, which is degree of freedom, and then there is F, which is the column contains the F statistics for each term, which is used to test the null hypothesis that the term does not explain a significant amount of variance in the dependent variable. The low F value indicates that the term does not explain much variance relative to the residual variance. PR and F. This column shows that the p-value associated with the F statistics. The p-value close to 1 suggests that there is no significant effect of the factors on the dependent variable, which is passenger count. Next slide, please. Now, here we shows, we will see the example. The p-value for day of week is 1, indicating that the day of the week does not significantly affect the passenger count. Similarly, the p-value for trip count is 0.687248, indicating that the trip count does not significantly affect passenger count. The interaction term between day of week and trip count also has a higher value of p, suggesting that the interaction does not significantly affect the passenger count. Combining all these insights, we will go to the next slide, please. Combining all the conclusion based on analysis for the NYC yellow taxi demand, we can draw several conclusions. First, daily consistency. The hourly distribution plot show consistent demand across all the day of the week, with y hat value ranging from 0.98 to 1.1. This indicates a stable baseline demand for taxi services. The peak hour, we observe slight increase in demand during the afternoon hours, particularly from 1 to 3 p.m. Suggesting that people are going for lunchtime and post-workout activities during that time. Next, moving to daily and decline. After 3, we show a drastic decline in the analysis and the demand for the taxi services. For future volatility, the time series forecast for February and March shows increasingly volatility, especially towards the end of the February. while daily and weekly patterns remain clear. This suggests growing uncertainty. In conclusion, with all the things that we have done so far, insights into taxi demand patterns can help operators optimize their services and adapt to changing conditions. Thank you.